So question 26, silver ions form the complex AgCN2-, so silver cyanide, so that's 2Cn-, with Kf is equal to 9.8 by 10 to 21. What is the minimum amount of HCN that would need to be added to a liter of a suspension of 0.01 mole AgCl in order to dissolve all of the solid? The KSP of AgCl is 1.8 by 10 to the minus 10, and the Ka of HCN is 6.2 by 10 to the minus 10. Okay. Now just another thing that I just thought about, okay, the chemistry syllabus is new, so it makes sense that the exam is a little bit harder for you guys because they're getting a little bit more used to it. Okay, they're sort of getting used to the new syllabus and designing their questions and things like that. So it makes sense that it's getting a little bit harder. So unfortunately, sort of in that period, in a couple of years' time, once they figure out what the standard is or how difficult or how easy the question should be, then it'll stabilize over time. But yeah, so that's where that is. So with question 26, it's got all the relevant content from your syllabus. It's a question you've never seen before. So it's a possible contender for the kind of questions they can give you, yeah, even though you've never seen it before because the syllabus is new. Yeah, there's a lot of things happening in question 26. Okay, first things first, silver ions form the complex AgCN2- with a certain Kf. Now, whenever there's a lot of things happening in a question, the first thing to do is to try to calm yourself down and make sense of the question and write out whatever information you know so that you can have it on the page and try to see it together. So at this point, I'm reading the question, I have no idea what it's telling me, okay? Why are there so many different reactions? And why are there 3 different equilibrium constants? Okay, so first things first, I'm just going to write out the chemical equations, write out what the equilibrium constants are so I can keep track of it and see what relationship is supposed to be there. Because if it's one question with 3 constants, there has to be a relationship somewhere, yeah? So that's my me trying to stay calm and make sense of the question. Okay, so first sentence, I get one reaction. Silver ions forms a complex AgCN2-. So that's Ag plus ions reacting with cyanide ions. And because there's AgCN2, there has to be 2 here. And it's a reversible reaction because I've got my equilibrium constant. So that's going to be AgCN2-. And that's Kf is 9.8 by 10 to the 21. And then they're asking me, what's the minimum amount of HCN that needs to be added to AgCl to dissolve all of the solid? So I don't really know what's going on there, so I'm going to jump straight to this. However, what I do sort of get from the question is that I've precipitated out, I have a precipitation of AgCl. A suspension, by the way, is when I've dissolved as much as I could. So that's AgCl. So that's where this KSP comes from. So I'm sort of putting some links together. And then I have HCN that I can put in to dissolve the AgCl, which sort of tells me that just after looking at that first sentence, it sort of tells me that, oh, when I add in HCN, even though AgCl can precipitate, when I add HCN, Ag would prefer to form this complex instead. That's why it dissolves, yeah? So I'm sort of piecing it together. And the fact that they've told me about HCN is why this Ka comes in, because HCN isn't a strong acid, so only some of it will come out, and only some of it will come out at a time to dissolve my AgCl. So I'm sort of putting my things together. But I still don't understand where I'm supposed to be starting with my maths, even though I sort of get how everything links together. So I'm just going to write out the rest of my equations. KSP, you guys know the KSP equation, AgCls turning into Ag plus AQ plus Cl minus, and that's KSP is 1.8 by 10 to the minus 10. And then I have the Ka of HCN. But Ka is just going to be 6.2 by 10 to the minus 10. The fact that 3 of my equilibrium constants go together to form just one reaction in which the HCN dissolves the AgCl implies to me that I want to be combining my three equations together. Okay, so to repeat, yeah, the question gave you the equilibrium constants for three different reactions. However, in the actual question that they gave you, the three reactions sort of happen at the same time. You add the HCN as it's dissociating and it's dissolving your AgCl to form the complex. So all three things are happening at once. So my next idea is probably I need to combine these equations together to see how HCN really relates to AgCl. Okay, so I'm going to combine these equations together to get one overall equation. So what's going to happen here is I can't really add it all together yet because I need to make sure everything balances out. And at the moment, I have 2Cn minus here and I have a Cn minus here. So I just need to multiply this by 2 just so I can bring it together, yeah? So what this just turns into 2HCN. AQ turns into 2Cn minus AQ plus 2H plus AQ. Now, when I multiply my coefficients, I square my equilibrium constant. Because remember, when you're writing your equilibrium expressions, the coefficients out the front become the power, right? So right now, it's just to the power of 1, which means there is really no power at all. And then when I multiply it by 2, the 2 becomes a power. So the expression stays the same. It's just that every concentration now has a power of 2 term on it. So the only way my equilibrium constant changes is that this becomes 6.2 by 10 to the minus 10 squared. So what I can cancel out is this and this now because they're on opposite sides. So what I have left is I have my Ag plus, AQ. Oh no, hold on. My Ag plus also cancels out. So that cancels out there. So I have AgCl and 2HCN, and you're sort of seeing the equation form. That's where my HCN reacts with my AgCl to dissolve it on the other side. Okay, so take it one step at a time. So AgCl S plus 2HCN AQ turns into, what do I have on the right-hand side? These, and these. Okay, so AgCN 2 minus plus Cl minus AQ plus 2H plus AQ. I've added my equations together, which means my equilibrium constants get multiplied. Okay, so you can write this out, like the equilibrium expressions for each of them, and see how they cancel out. But so please, if you're extra confused, have a go at doing that. But just in terms of like a simple explanation, because it's going to take a bit of time to write out the expressions, your equilibrium expressions is products over reactant concentrations. So then when you add up all of your equations, all of the products now go on the top and then all of the reactants now go on the bottom. So it's sort of like you're multiplying your equilibrium expressions. Can I get a thumbs up, guys? Does that make sense to you? When I add my equations together, the equilibrium constants multiply because all the products end up at the top and all the reactants end up down the bottom. Yeah, so if you're extra confused, please write out the equilibrium expressions for each of them, Kf, Ksp, Ka. But yeah, that's the more simplified explanation. So the K of this now summed up equation is going to be K is equal to this multiplied by this multiplied by this. Okay, so that's 9.8 by 10 to the 21 by 1.8 by 10 to the minus 10 by my 6.2 by 10 to the minus 10 all squared because I've adjusted that equation. Okay, 6.2 by 10 to the minus 10 all squared. Now, if you want to pop this into the calculator, that gives you 6.8 by 10 to the minus 7. Okay, so now the reason why I approach this question this way is so that you guys don't think that there's sort of just like a memory that you can, sort of like a method that you can just memorize. Yeah, technically, if you do enough of these questions, you do memorize it. But I want to show you that there is a way for you to get around the difficult questions in the exam. Yeah. So if you're ever confused about a question, write out what you can know and try to see how they link together, okay? Now, I know this is a multiple choice question. In the exam, this whole document is titled challenge questions. Yeah, so don't think that it'll come up like this. If you get a question like this, it'll be like a 5-6 mark question in the HSC. Yeah, they won't make a multiple choice out of this. That'll be very cruel of them. So now you're sort of seeing where it comes together, okay? So this is sort of like the light at the end of the tunnel, okay? I've now got an equation that relates the AgCl they're talking about to the HCN that I'm using to dissolve it, okay? So now you're sort of seeing I've got an equilibrium equation, I've got the expression, I can start to substitute in my initial values in my ice table, okay? So at the moment, what they've told me is, can get rid of that now. What they've told me is my initial value is, I don't know the initial value of HCN, that's the thing I'm after, okay? But I do know the initial value of this, okay? So that's gonna be my I value. And then because the question hasn't given me any other numbers, everything else is gonna be 0, okay? So then that goes back to your regular ICE table question. If there's 0 products, the equilibrium is gonna shift to the right. So it's gonna be plus X, blah, 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 okay? So ICE gives me, now this is sort of where your thing comes in, right? We'll do a couple more questions on this, but in terms of like whether or not you need concentration, so just as a heads up, whenever you're using your equilibrium expression, it's always in concentration, yeah, always, yeah? So whenever you substitute everything into K is equal to concentration of products over concentration of reactants, it always has to be moles divided by volume. Sometimes the question gives you really funky looking volumes, and it's just not fun to work with the volumes in the ICE table. So what sometimes people do is they deal with the ICE table in moles, and then when they substitute it into the equilibrium expression, they divide it by volume there. So that might be where your confusion's coming from. So in terms of that, the trick there is to be very aware of when you're using moles and you're using concentration. To be honest, the trick with that is just going to be doing a lot of KEQ questions and being able to identify parts where it's easier to use concentration or easier to use moles in your ICE table. However, if you're struggling, my recommendation would be to just pick one method so that you never get confused with it. So sometimes using concentration in an ICE table is confusing, but if you struggle to switch between moles and concentration, just stick with concentration, yeah? So ICE table, moles or concentration, KEQ always has to be concentration, but if you struggle to switch, ICE table, just do it in concentration. So moles divided by volume every single time. We'll go into more a bit of that later, but just as a heads up for you. So in this case, they've given me 1 liters of 0.01 mole. I can do it in moles if I wanted to, but because liters, it's just 1 liter, it's just really easy for me to convert it to liters straight away. Mostly because moles and moles and concentration is just the same thing. Okay, so concentration is moles on volume, which is 0.010 divided by 1. So that's just going to be 0.010 molar. Yeah, so that's going to be my initial values that I substitute into here. So 0.010, and then this one is the thing I'm looking for. Remember, okay, that's the thing I'm looking for. So that's just going to be, I don't know, let's just call that X. Okay, and then remember, the question hasn't given us anything else, so that's just going to be 0, 0, 0. Okay, and then because I'm dissolving AgCl, that's what the question told me, it's all going to shift to the right. Okay, now you might be wondering, why did I put X in the I box when usually we use X in the change box? Okay, the thing is, with this question, I don't need another variable, because if I need another variable, the question's never going to get answered. There's too many unknown variables. They asked me to dissolve all of the solid. Okay, so I know what my change is. I don't need to put my X. For me to dissolve all of solid, I'm getting rid of all of this. Okay, so that's why there's no X here. So I could have used any letter over here. I just used X because it's every unknown is an X. Okay, so because they told me I'm dissolving all of my AgCl, it's just going to be minus 0.010. So it's going to be minus 0.010. That's going to be plus 0.0. Oh, hold on. use my coefficients, that's a 2. Okay, so for every 0.010 of AgCl, there's a 2 times that of HCN. And then this is 1, this is 1, and this is 2. So that's going to be plus 0.010, plus 0.010, plus 0.020. Okay, so then my final values is going to be x minus 0.02, 0.01, 0.01, 0.02. So now I found my equilibrium concentrations. I can substitute it into my expression to get my final answer. Okay, so this is sort of going back into your regular answer. So you're sort of seeing this question doesn't actually take that long. It was just about trying to understand what the question was even asking at the start, yeah? So now my K value is the concentration of AgCN2 minus, the minus goes inside, with the Cl minus, with the H plus, and remember the coefficients get squared up the top. And I have my, technically my AgCl doesn't even go in it because it's a solid, so I can get rid of that. So it's a pure solid, so I don't need to pop that in at all. So it's just going to be HCN squared. Okay, so then I'm going to pop my values in. That gives me 0.010 by 0.010 by 0.02 squared divided by my HCN concentration with my unknown variable that I'm going to move around and try and find. That's x minus 0.02 squared. And that's going to be equal to the equilibrium constant that I had moved around to try and find. So that's 6.8 by 10 to the minus 7. So now my job is to move everything around to get x. Okay, so I'm going to move this over and I'm going to bring this over. So x minus 0.02 squared is going to be my 0.010 by 0.010 times 0.02 squared divided by 6.8 by 10 to the minus 7. Okay, now to save you guys popping each step into the calculator, because there's a squared on it, I can square root the whole thing. Okay, so x minus 0.02 is going to be that square root of the fraction. And then x, I'm going to move this 0.02 over. So x is going to be square root 0.010 times 0.01 times 0.02 squared divided by 6.8 by 10 to the minus 7 plus my 0.02 at the end. Okay, if at any point you're confused about the maths, please let me know. Can I get a thumbs up so far? Is it making sense to us? All I've done now is substitute it regularly into my ice table and move my expression around, okay? So now, adding it, just moving it around to get my x is going to give me 0.26 moles. Oh, sorry, that's moles over volume because I've used my ice table in terms of concentration, okay? However, remember that the volume that I used at the start anyway was only 1 liter, right? So if this is moles over volume, just for me to keep my units the same, but just keep in mind, so this is going to be the concentration of my HCN, but then my moles is just going to be C times V, which is 0.26 by 1 liter, which is just going to be 0.26 moles, okay? So my answer for this question is, leave that there for a second, just in case anyone's still getting it down. My answer for this question is going to be 0.26 moles, which is going to give me C.